So the name of the topic is active vibration control. Hmm? And the CO which is connected with this is apply suitable active vibration control techniques to control the vibration to acceptable level. So the topic name is active vibration control. This is our module number 4. Okay. In this, we are going to study the classification and modeling, actuators and sensors for vibration control. Then after this, we will look for active vibration absorption and damping. And later on, we will study with the classical control, optimal control, piezoelectric transducers for active vibration control. And then we will proceed for the what are the different techniques related with the semi-active vibration control, which includes magnetorheological fluids, then magnetorheological models and devices, and then we will proceed for semi-active suspension, and we will look for a phenomenon which is called a narrowband disturbance, which is based on the frequency response for a particular range, right? So we will focus on what is the given frequency and what is the techniques to be used for reduction of the response. So let us look at the points that we need to discuss. So whenever we are considering the word introduction to the active vibration, first we will the topic that is going to consider introduction to active vibration control. So first we will look for what do you mean by the active vibration, right? So active vibration involves the use of sensors and actuators for the neutralizing the vibration which is exerted on the system. So in this case, we will first look for which are the existing vibration control techniques for the different reduction of the sources, and then we will look for what do you mean by the active vibration and how does it plays the important role in reducing the vibration. The which are the vibration reduction techniques or vibration control techniques? The first is the reduction of vibration at the source. Then second is vibration isolation. Third is system modification. Right? Now all these techniques, if you are going through, these are all are passive techniques, right? Now, if you going in detail, then what are these techniques indicate, right? Or what do you mean by the source modification? So, if I consider what is the reduction of vibration at the source, then we wanted to reduce the source of vibration. So, how we can reduce? Suppose there is a pump, and this pump is producing the unbalance, and because of this unbalance, the vibration is getting increased. So what we can do, if the pump is producing the unbalance, so we can balance the pump more accurately. So which is nothing but can be considered to be as the reduction of vibration at the source, also known as the source modification. Now wherever we are considering the vibration isolation, so in that case, suppose the pump is kept on some uh, base. So what we can do, to attach a pump to the base through the flexible anti-vibration mounts instead of the rigid fasteners. So if you are mounting the anti-vibration mounts below the pump base, that will reduce the vibration being transferred to the foundation, thereby achieving the vibration isolation. Then what do you mean by the system modification? Let us say uh, the same pump is kept on some system, and it is covered by a large panel or large cover panels. And what is happening, because of the uh, noise which is generated because of the panels, right? The system is getting resonate, and some noise is generated towards the surrounding, or the noise is transmitted to the surrounding. Now what we can do, the large cover panels which are surrounded to the pump is the basic problem. So to address that problem, what we can do, we can add some ribs on the panels, thereby stiffening them so that their natural frequency gets shifted well above the excitation frequency, that is above the rotational speed of the pump, which can be considered as system modification or system modification by the structural redesign. So all these techniques are essentially a passive vibration technique. Okay. So now what can be considered to be as a semi-passive? Now semi-passive or the semi-active is another class. The semi-active, or also known as semi-passive, involves the energy harvesting. We will discuss about this energy harvesting later on, whenever we are completing with the active vibration, right? Let us understand the third class first. What do you mean by the active vibration control? So this active vibration control involves the classical, modern, and the distributed control. We will understand in detail all the contents related with this. What do you mean by this? Classical, modern, and the distributed control. First, look at what are the contents. So in the contents, we will discuss about the on which principles the active vibration control works. So active vibration control system operate on the operate on principles of automatic feedback, or it can also be known as feed forward control. Automatic feed control or feed forward control. And thus all the fundamental attributes of the closed loop control system that we are going to discuss ahead. So what is the active vibration control system does? The active vibration system does, let us call it as AVC, active vibration system, favorably modifies the structural response by means of one or more actuation. Now, what do you mean by this actuation? As active vibration involves some involvement of the sensors and actuators. So, what we wanted to get a response of these sensors and actuators by the different means. So, what we can do, we wanted to alter the structural response with the help of these actuators or the sensors. Okay, how we are going to do? So, this we are going to do by structural response is by applying secondary forces. These are also known as control forces on the vibrating elastic structure by means of one or more actuators. So what we are trying to do in this case, fundamentally an active vibration control system modifies the structural response by applying the secondary forces, and the secondary forces are known as control forces, right, on the vibrating elastic structures by means of one or more actuators. Now let us understand what do you mean by the different elements, or what is the importance of the different elements. The first element that we are going to consider is called as controller, right? So what is the controller? It is basically an electronic component, or we can also call it as a microprocessor in the modern applications. Okay, and what it does, it does, or it determines the exact nature of the control forces produced by the actuators on a well formulated control laws which utilizing the feedback of the response of the structure. So what it does, it is an electronic component of microprocessor which determines the exact nature of the control forces which are produced by the actuators on a well formulated control laws. And how it does, it does by utilizing the feedback of utilizing the feedback of the response of the structure measured by one or more sensors. Now, where do we place these sensors? So we place the sensor at different locations, right? So which are placed at different locations on the structure, right? So essentially, controller determines the exact nature of the forces produced by the actuator based on the well formulated control law that utilizes the feedback of the response of the structure. And now how we can measure the feedback of the response of the structure? By using one or more sensors. As we wanted to measure the response, so sensors needs to be placed at the different locations on the structure. So we will have to do that, right? So how do we do the successful active vibration control? For successive active vibration control, what we need to do? Control law is so formulated that corresponding control forces essentially modify the effective mass, damping, and stiffness properties. Stiffness properties of the structure, of the essentially vibrating structure. Now how they are going to do? By electronic means. In a which manner? In a desirable and frequency dependent fashion without violating space and weight constraint. So how we are going to do the this vibration control? Yes, Aditya.
सर आय हॅव अ सजेशन लाईक तुम्ही आता लिहिताय ना तर मग म्हणजे जॅम बोर्डवरती लिहिण्यापेक्षा तुम्ही टाईप टाईप केलेला बेटर पडेल तुम्हाला पण आणि आम्हाला पण म्हणजे तुम्ही ते माऊसने लिहिताय की नाही मला माहित
नाही
नाही
नाही नाही
कशाने
माऊस
लिहिताय.
नाही माझ्याकडे पॅड आहे.
अच्छा ओके.
रायटिंग पॅड.
अच्छा अच्छा ओके. मग काही इश्यू नाही म्हणजे इक्वेशन काही नसेल तर मग तुम्ही
हा 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 येस येस. नाही मला स्मॉल स्मॉल डायग्राम्स आहेत.
टाईप
हा
केलं
जास्त
तरी
बेटर आहे टाईप केलेलं. येस
ते
करेक्ट करेक्ट.
बेटर.
यू आर राईट. येस. सो एक स्मॉल डायग्राम्स आहे तिथे आपण शिफ्ट टू जस्ट फक्त बेसिक बॅकग्राऊंड सांगायचं होतं आधी मला.
ओके सर ओके.
येस. Constraints imposed by particular application. Now, which are the advantages posed by this over the active vibration controls? advantages of passive, advantages of active vibration control over passive vibration control. The first is effectiveness over broader frequency range within the limitations of actuator capacity. So what is the meaning of this? Effectiveness over the broader frequency ranges within the limitations of the actuator capacity. So actuator will have a some certain capacity over which it is going to operate, right? And there will be a broader frequency range the instrument will have, right? So within the limitations of the actuator, we will get the more effectiveness over the broader frequency range that can be achieved by using the active vibration control over the passive. So we can say that the actuator will be much more effective in controlling the vibration compared with the passive vibration control. That is the basic meaning of this statement. The second is relative insensitiveness to operating conditions. So it is not going to be affected by the operating conditions. So which are the operating conditions that may be subjected to, such as external force, right? External forces is not going to affect the operating conditions of a actuators. Then the third disadvantage is greater flexibility in terms of control objectives, which can be optimized based on specific needs. So this active vibration control provides greater flexibility in terms of the control objectives, and these objectives can be optimized based on the different needs of the situation, right? Now let us look at how does it does. So take an example of the incoming vibration. Let us assume that this is the nature of the incoming vibration if you are measuring on a x versus time graph. Okay, so let us assume the displacement is on a x-axis and the time period is on the x is on the displacement is on the y-axis and the time period is on the x-axis. So this is a incoming vibration. Then let us assume the oscillating signal which is provided by the oscillator or the actuator on the same time domain as like this. Now if you closely observe, it is having the opposing nature to the incoming vibration. So this is a oscillating signal. Let us call this oscillating signal having an amplitude of this, or this can be considered as a displacement. Okay. Now let us combine these two and let us see what is the effect in this case. So upper graph shows the incoming vibration, whereas the lower shows the oscillating signal. Now here the case is reverse. Oscillating signal will come from the upward side and the incoming vibration is on the downside. In this way, we can see that the incoming vibration and the oscillating signal are opposing in nature. So we can call this oscillating signal as the cancellation signal. Okay. So it can be also called as cancellation signal. So in this case, if this is the amplitude, right? So incoming vibration and cancellation signal are transposed each other. So those both are overlapped with each other, and we can see that both are neutralizing the vibration, or both are having the opposite sense. So the total vibration which is experienced by the system is getting neutralized. So what is the net effect? We can see the net effect of the vibration. We can see that this is a zero net effect. Okay, on a time scale. Okay, if this is the vibration we are measuring, we are experiencing that there will be no there will not be any vibration that will be subjected by the system, because what is the actuator is going to do? Actuator is giving the vibration to the system in the opposite direction, whereas system is getting vibrated in the suppose downward direction. The actuator is going to give the amplitude of the motion in the opposite direction to the vibration, and we will get this pattern. So this is how the active vibration system works. Now let us understand how to find out the nature of the incoming vibrations. So to know the nature of the incoming vibration with the help of sensors, so which are the different sensors we need to know the nature of incoming vibrations? We need to understand the nature of incoming. So to understand the nature of incoming vibration, we have to use the different sensors. So which are the different sensors we can use? So we can use the different sensors such as, first is accelerometer, right? So what is the accelerometer is going to give us? It is going to give us the what is the values of the acceleration, right? Then we can use the velometer for the measurement of velocity, and to get the position of the system, we can use the piezoelectric systems. Now, to know the nature of the cancellation signal, because this is the nature of, these are the sensors that we can use for incoming vibration, and to neutralize this effect or the response which is provided by these sensors, we also need to understand the different natures of the cancellation signal. So to know the nature of cancellation signal, what we need? We need actuators. Now what are the different actuators we can use? The first actuator we can use is called as smart actuators. So as the word indicates smart, so which are based on the smart materials. Then we can use the electrohydraulic actuators. We can also use electromagnetic actuators, we can also use electro pneumatic actuators for generation of the cancellation signal. Okay, so once we know the response which is provided by the incoming vibration through the one of the sensors, what we can do, we can use the different actuators to generate the cancellation signal which will neutralize the total vibration produced. So, what we can do, the technique which is shown in the figure, that is these figures, right? So it is necessary that active vibration control shown to be absolutely necessary for vibration control in space structure, right? Where passive vibration control causes very high weight penalty, causes high weight penalty, because whenever we are using the flights, right, even for 1 kg increase of weight beyond the allowable limits, you know that lot of money is being charged. So that's why they are very much strict about the weight controls of the flight. So there are isolation systems that dynamically react to incoming vibrations rather than passively reducing their effect by virtue of their mechanical structure, right? So let us take an example, operating equipment like car engine. So in the car engine or an altitude control assembly in a spacecraft, what do? They generate oscillatory forces which can propagate in the supporting structure. So a vibration isolation is necessary, and this is the purpose of the active vibration control system. And what is the example that we can use here to reduce the vibration? The example that we can, or the techniques that we can use for reducing the vibrations which are generated because of the oscillatory forces which get propagated into the supporting structure by using the active vibration or active suspension system. So we can use the active suspension system. What they will do, they will neutralize the vibration being transferred to the supporting structure which is generated because of the oscillatory forces being propagated, produced from the source. Okay, correct. So when it was first devised, so it was first devised in the International Space Station. International Space Station, ISS, which involves the group of space structures. These are also generally called as large space structures, right? Now the question is, why do we have to use the active vibration control for a international space system? So let us address that, then we will proceed towards the different applications of the traditional applications of the active vibration control. Why active vibration control for International Space Station? The fundamental modal frequency of the ISS is around 8 Hz. Fundamental modal frequency for ISS is equals to 8 Hz, and the corresponding structural damping and the corresponding structural damping is only about 0.358%. So in case what is this, a damping is very less, so we can say this is a classic case of flexible body with very low inherent damping. Flexible body with very low inherent damping. Okay. So in such case, if we are going to use the passive vibration techniques, then it can cause the continuous, if you are going to use the passive vibration techniques, then there might be a chance of the very large increase in the weight. So active vibration is the only feasible solution in such case, and if poor damping in the absence of air causing the continuous vibration of the structure, then what is going to happen? There might be a fatigue failure of the different parts of the ISS. So it will be a very large damage to the structure as well as to the astronauts which are continuously on the ISS for the different purposes such as monitoring as well as the maintenance purpose. Okay, that's why the active vibration control was the feasible solution in such cases. Okay, are you able to understood the example?
So will you please repeat the question?
Okay, what was the question? Why the active vibration control is feasible in case of the International Space Station? So we understood that in active the fundamental modal frequency of ISS is only 8 Hz, whereas the corresponding structural damping which is provided by the different parts is only 0.35%. So which means that there is very less damping or very less inherent damping of the structure. So in the absence of air, because of the pure damping, there will be continuous vibration of the structure which may otherwise cause fatigue failure. So if we are using the passive vibration control techniques, then we will have to add the weight to the system, right? So to avoid the weights, the only feasible solution was the usage of the active control vibration techniques. Okay, getting, or it becomes difficult online.
Yes, sir.
Okay,
Uh, no, sir.
anyway, online is
A bit थोडा थोडा वेगळं वाटतं ऑनलाईन मध्ये, पण
oh yes.
ठीक आहे, चालेल.
Okay. I am sharing the notes after this lecture. Hmm? Let us understand with the traditional applications of the active vibration control. Traditional application of ABC. Suppose this is a structure. So ABC can also be used in more traditional applications like control of vibration due to excitation forces like earthquake or wind or unbalanced motors and waves. So let us take a control system integrated with the range of actuators like electromagnetic, electrohydraulic and pneumatic actuators. What do? They provide the counteractive actuation force such that motion of the structural system could be controlled. So let us draw one structure. I am taking one structure, right? And on this structure, let us mount the different sensors. Let us say this is a sensor 1 and this is a sensor 2. So these sensors are collecting the collecting the signals, and they are transferring the signals to the signal conditioner, which is denoted by the symbol S, right? So now these are transmitted to the feedback control. So let us denote the feedback control by FBC. Okay. After the feedback control, then these are transmitted to the feed forward control through the summing junction. So let us we have the summing junction. So this is a summing junction which the feedback control is transmitting the signal, and here we have actuator F. This actuator is connected to the feed forward control, which is also connected to the summing junction. Then we have the system which is receiving the power or which is transferring the power to the actuator. So this is a mass of the coil housing. Let us denote it by M1. It is transferring, it is connected to the power amplifier, and this power amplifier is connected to the summing junction, and these are connected to the ground. Okay. And we have this is the reference signal. So in this case, this is the vibration control by using the electromagnetic actuators. You can see the different elements of the system, and to this mass of the coil housing, or the this M1 is called as the proof mass. We have attached the system with the spring and stiffness. This is connected to the ground. This is K1 and this is C1. So what is the K1 and C1? These are the springs and dampers. So in the active vibration control, most machines and structures are required to operate with low levels of vibration, as smooth running leads to reduced stresses and fatigue and little noise. Right? So active vibration control have emerged as viable technology to fill low frequency gap of the passive vibration control. So what is this are doing? Sorry. So most machines and structures are required to operate with low levels of vibration, because that is the need of the today's world. And so what is the effect of if the systems are running with the low vibration level? Smooth running will be the of the different components, which in turn will provide the reduced stresses and fatigue, and also the less noise that will be produced. Okay, so because of the applications like this, vibration control by electromagnetic actuators. What we can do, because of the reduction in the stress and fatigue and less noise, life of the machinery will get increased. So active vibration control has emerged as a viable technology to fill low frequency gap of the passive vibration control. Then active vibration isolation systems are most effective at low frequencies and large amplitude of the vibrations. So the active vibration isolation system reduce when it is more useful when most useful AVC, most useful at low frequency and large amplitude of vibration. What do they do? This system reduce and compensate disturbing force, or we can say as the disturbing force is producing displacement, so we can also say that they are also reducing the vibration displacement, or the amplitude of the vibration is getting reduced by by additional energy source. On what is the additional energy source? The additional energy source is nothing but a actuator. So these systems are usually used or these systems are usually using positioning mechanisms, or we can say these systems are actually using the actuators. Okay, the where do we find out the most useful? At low frequencies and the large amplitudes of vibration. And how do? They reduce and compensate the disturbing force or vibration displacement by additional energy source, right? So additional energy source is provided by the actuator, and these systems are usually used for positioning mechanisms or positioning actuators. Second, these actuators compensate vibration displacement due to closed loop control system. Control system with feedback. So, as we are using the closed loop control system, we are getting sure whether the vibration is getting really reduced or not, right? So we can see that in the figure which I have shown, this system is basically an example of the closed loop control system, right? So in this closed loop control system, this F is the actuator, then feed forward control, then this is the feedback control. So all the data which is provided by the signal condition to this will get again analyzed, and we will get whether the actuator is really providing the disturbing force or the displacement which is opposing to this structure which is providing the vibration or which is producing the vibration. Okay, so we can adjust the amount of the actuating force which is required for the actuator to operate. Okay, so let us understand it by using a block diagram. So let us we have a structure at the center. Then we have the external excitation, which is being transferred to the structure. So we get the structural response. Okay. Now what we wanted to do, we wanted to measure the structural response. How we can measure? With the help of the sensors. So we are using the sensors to measure the response, right? Now once this sensor response is sensed, what we need to find out? We need to find out what is the computation of the forces. Okay, because these sensors are giving some output, we need to convert that output into the desired nature. We will also going to sense the what is the external excitation which is provided to the structure, right? So that also we are going to do by using the sensors. Then these sensors are providing data to the control system or the our main analyzing element. Then what we are going to do, we are going to transmit that amount of actual force to the actuators. Okay, so we are transferring the amount of the required force which will transmit the displacement to the vibrating member in the opposite nature. So these are going to control the forces. Control the forces which are being transmitted to the structure. So which are the major components in this case? Major components are actuators, sensors, and controllers. Okay. So in this way, we can have the and active vibration control system and its elements and interactions of the system with the controlled mechanical structure. Okay. Now the third point in this, as the force is applied on the structure varies, force applied on the structure varies. The sensor senses the response, correct? Then what the next thing to do? Once the sensor senses the response, the controller receives the signal and transmit the signal to control actuator. The actuator develops force or motion proportional to the command signal, right? And it controls the, thereby it controls motion of the structure. Okay, so in this way the active vibration control techniques work. Hope you understood somewhat. Any questions related to this? Hello.
No, sir. No question.
Okay, whether you understood this little bit, active vibration control is what, how does it does?
Yes, sir.
Okay, okay, so now we will proceed towards the different aspects related with the this part. Now, as there are some advantages of the active vibration control, right? There will be some disadvantages also, right? Or the limitations we can say. So let us look at the some of the limitations of the active vibration control techniques. Then we will proceed toward the detailed insights. Limitations of AVC. The first is an AVC is always costly and works within frequency bandwidth. Works within frequency bandwidth of the controller and is susceptible to instability, susceptible to instability if not properly designed. However, any active vibration control requires an external source of electricity for its operation. We know that electrical source is required. Electrical source for its operation is required. Correct? Let us look at the second.
सर स्क्रीन विजिबल नहीं है.
Acha, wait. Sorry. I think I need to share it through a tab. Yes. So what I told you, limitations of AVC, and AVC is costly and works within the frequency bandwidth of the controller and is susceptible to instability if not properly designed. And as active vibration control requires the electrical source always for its operation. Okay. This is one more additional thing whenever we are considering the active vibration control. Moreover, electrical source for its operation is required. So let us look at the second. In event of failures of active devices. Which are the active devices? Many active devices are there, such as power failure can cause the failure of the devices, or malfunctioning of any electronic part or electrical part, malfunctioning of electronic or electrical components. If the control loop stops working, which can lead to failure of whole system. Lead failure of whole system. Right? So, under such circumstances, semi-active or hybrid control methods are preferable to fully active control. So, in such cases, whenever there is a chance of the power failure or the malfunctioning, what we can prefer? We have to use, or we can go for semi-active or hybrid control methods over over full active control. Okay, then let us look at the third case. A hybrid vibration control system, that is an combination of and combo of active, passive, right, can combine the advantages of the both, that is passive and active control system, when the active control loop operates when an active control loop in control loop operates in synchronization with passive control device. Okay, because of which when active control loop fails, because of some reasons or other reasons beyond control, the passive control components provide the necessary support. Necessary supports, thereby providing fail-safe nature or fail-safe support to the system. A good example of such case is active tuned vibration absorber. In the previous sessions, we understood about the tuned vibration absorber, in which we see that the passive elements are used, such as the spring and mass, which are reducing the response of a system, right? So with the help of this active tune vibration control, we can use the hybrid vibration control technique. So we will discuss now what is this ATVA. ATVA, active tune vibration absorber. So it is designed to enhance performance of passive tuned dynamic vibration absorber, that is abbreviated as dynamic vibration absorber. Now how it is used? By using an active force generator placed in between host structure and secondary mass. of the passive. Secondary mass of the passive, that is dBA. Where does it place? It is placed between the host structure, right? What do you mean by the host structure? The structure which is getting vibrated and the secondary mass of the dynamic vibration absorber, which is nothing but acting as a passive element. Okay. So what does it uses actively? So active force generator is driven by an optimally configured controller, which is based on suitably or suitable sensory feedback, suitably obtained sensor feedback of the vibratory response of the structure. How does the active force generator in the ATV works? It is driven by the optimally configured controller, and this optically configured controller is working on the suitable sensor feedback, which is based on the vibratory response of the structure. Okay. So if in case failure of the active control of the performance of the system, then still there is a passive system is there. That is, if the active control system is failed, active vibration control system is failed, or active control system is failed, we still have passive, that is dynamic vibration absorb is there. So we can say that stability of system is maintained or not sacrificed. So there exist diverse semi-active vibration control methods that operate on, so semi-active vibration control techniques, so that obtain on modifying and modulating the stiffness or damping characteristics of the passive vibration devices or passive vibration control devices in real time. Passive vibration control devices in real time, and so are consuming less power. So consuming less power. So there are certain devices which are reducing the, or which are modifying the stiffness and the damping characteristics suitably by consuming small amount of power. So those systems are called as semi-active vibration control techniques. Okay. So let us take an example of this. So the examples for this are examples of semi-active devices. The first is variable orifice dampers. Second, smart fluid dampers. These are also known as magnetorheological fluid dampers. Magnetorheological fluid, also abbreviated as MR dampers, which are widely used for, these both are widely used for semi-active force generators. So what happens in the viscous damping coefficient of the this orifice dampers? So in such case, variable orifice dampers the viscous damping coefficient, that is C, of an this orifice damper is modulated or can be modulated by changing magnetic field, by changing magnetic field across the orifice, across the orifice, and thereby corresponding power requirement is so small, power requirement is so small, it can be operated with low voltage batteries or low voltage battery sets. Okay, so thus we can say that semi-active control devices in one hand offers all the advantages of the passive devices. Like, what do the passive devices provide? Passive devices provide robustness, reliability, and cost effectiveness. And on the other hand, these are closely comparable to a fully active system in terms of their performance. Okay. Okay. Yes, Aditya.
Sir, for content regarding this
I'm
module,
sharing the PDF.
uh, sorry,
I'm sharing the PDF notes of this module.
sir, no, sir, that's not the issue.
Huh.
If I have to refer any book, so which could be that
Uh,
Shyamalan Chakraborty would be right for this content or
yes,
any
yes.
other book?
Uh, if you want a detailed, right? The book of
Yes.
the Malik and Chatterjee is okay.
Mhm.
Then for module 1 and 2, SS Rao vibration isolation module is also okay.
Okay.
Hmm. Now, regards to the solution of the equation we have obtained in the previous lecture, that is of the dynamic vibration absorber, actually it
Yes.
uses the matrix method. I found out that matrix method can be useful, right? That's why I found out that some of the steps are skipped, right?
Yes, sir.
Yes. So I will provide the steps for that solution. And
Okay, sir.
regards to the this module number 4, 5, and 6, I think only this book is available. Malik and Chatterjee. No other book will provide the contents. I will also share the different books, e-books available, but the data will be very scattered.
Okay.
Uh,
Okay, sir.
yes, yes.
Because I saw the content regarding active vibration systems, and that in the book, I guess it is Henry Fremont,
Yes, yes,
Andre Fremont, but it's very deep
yes. It's
regarding
too much deep.
piezoelectric. Yes, sir, it's too deep. Piezoelectric beam, electromagnetic and piezoelectric transducers. It's sometimes it gets out of context. So that's why I asked.
Yes, yes, yes. So this book is much better compared with that. Although the some of the mathematical expressions provided are very critical.
Yes, sir.
Yes, but regard except that the other content provided is very good.
Yes, sir. They like the context in which they are explaining. It's very applicable. Means it's application based. So it's amazing to read.
Yes, yes. So we will broadly classify, or we will see broad classifications of the active vibration control strategies for today, and then we will stop. Okay. So how do we classify the active vibration control strategies? Based on the different parameters. So active vibration control. So classified on the control strategy. We have feedback. So how do we get the feedback? Based on the control forces, or what is the purpose of the feedback in the control strategy? To get the control forces determination based on the measured forces. So control forces based on measured response. This is the use of the feedback. Then what is the purpose of the feed forward? So the control forces are determined based on measured excitation or some signals directly relative to the excitation. That is the purpose of the feed forward. Control forces are determined based on the measured excitation and or some signals directly related to the excitation. Then we have feedback, feed forward. So it is a combined feedback and feed forward control. These are factors related with the control strategy. Now let us look at the control devices. So in the control devices, we see that the first is fully active. So fully actives involves the actuators which apply the dynamic control forces. Okay. The second involved is semi-active, so which involves stiffness and damping properties of passive vibration control devices which are to be changed to adjust internal dynamic forces. So stiffness and or damping properties are changed of passive vibration control devices to adjust internal dynamic forces. The third is hybrid. So hybrid involves active and passive control which works simultaneously. And the last is adaptive. So adaptive are control or controller and actuator parameters are changed online according to the operating conditions. So the controller and actuator parameters are changed online according to the change in operating conditions, such as if the operating condition is changed, then the controller or the actuator should be able to provide the appropriate response to reduce the vibration being transferred. So it is also known as the quasi-static. Okay. So these are the different techniques related with the classification of the active vibration control strategies. Broad classification of active vibration control strategies. Okay. So we will stop for today.